Today I'm going to try to show you how I build Streamlit apps using AI. And we're going to do this kind of totally from 0 to 1. I've got no code written. I've got no folders structured. I don't have anything actually set up at all. So we're going to have some edits in here, but overall, I want to offer you the actual feeling of what it's going to be like to try to create a Streamlit application, leveraging what we'll be using as Cursor today, but any of your AI copilots or other LLMs that you want to use to build this particular type of data platform. So real quick, what is Streamlit? Well, Streamlit is a Python API over a web development framework that is centered around data applications. I'm going to show you that, but I'm going to show you how I can build it by just using AI and Cursor. So let's get into this. So in the beginning, I just made a directory called Streamlit Ideas, but we're going to create our own project here. So we'll make a directory and we're going to call this application what? Well, let's say we're going to say it's an AI test. It's not my best, but we're going to go with it. Let's go into AI test. Okay, so Streamlit is a Python package, which means it needs an environment to function in. We want to create an environment before we start running Streamlit and doing other things. Why do we create an environment? If this is the first time you've heard this, it's because you will have different libraries and versions of those libraries that you're probably going to leverage from app to app in Python. So normally the way I do this is I use UV Astral. UV Astral is written in Rust, and it is a package that lets you parallelize the downloading of packages. For Streamlit, Streamlit is a big library. And when I would used to use only pip installs, it's single threaded and it took a long time. Astral UV just rips through it, and that's pretty cool. But I'm trying to show you how AI will get used to make the entire application. So I've got my chat open here, and I'm going to be just in chat. I'm not going to be an agent. I'm using Cursor, FYI, so I'm just going to ask. So the first thing I'm going to ask is make a virtual environment using Astral UV and Python 3.11. I have Python 3.1 installed on my computer, but when we create the environment, we want to tell it specifically, let's use that. So we're going to see what comes back and tells me. It should go relatively quickly. I think we are leveraging Claude, but this is a pretty straightforward question. I already don't like this. So Gemini Pro 2.5, that was my problem right there. Let's get over to 3.5 Sonnet. Run that. I don't want a thinking LM. Just get to it. Show me. All right, cool. Great. So what we've got here is UV-env Python 3.11. I'm in my directory. I'm going to run that. It gets created immediately. I don't even need to type here still. I'm just going to keep doing what it's giving me. We're going to activate that, and then we'll double check the Python version. Great, 3.11. So we've got our environment activated, and now we have our Python version confirmed. That's what we're going to use. So let's create a new thread at this point. Let's zoom in a little bit, okay? All right, so we got our folder and our virtual environments right here, which is fantastic. All right, now what do I want to do? Okay, I need, well, let me back up real quick. Not only do we need a virtual environment, but we need a requirements text. One of the things that is useful is once you're in a virtual environment, which we are in, you can use the requirements text to read the libraries you need. So you can tell the virtual environment only install those packages. So what I'm going to ask Claude here as well is make me a requirements.txt along with all necessary libraries to create a Streamlit page. I will say Streamlit application. So it's made this underneath, which is great. I like to hold off on accepting things until it's gone through all of it. But yeah, you'll see it's kind of told us what it's gone with here and what the pip install looks like. So it's going to make some decisions, okay? I have my own decisions about things, and I'll probably make some updates here. Let's go ahead and accept this. And let's see what they did. So they went with Streamlit 1.31320. The first thing I'm going to say is it will make the requirements text. It will put in the libraries that you need. Where it gets wacky is version numbers. This is where the LLMs, honestly, they fail here. I have to always revalidate the version numbers. However, while this is not what I suggest, what we're going to do this time around is we're going to actually remove version numbers. And what that means is it is going to go and get the latest version of all of these packages from the get-go. Let me get back to what it added, and we're going to decide what we want to keep, okay? So Streamlit, 100%, we have to download Streamlit. Pandas, we will go ahead and download Pandas, but I'm also going to add polars, and I'm going to use polars. NumPy, we'll leave that there. Plotly, that is my preferred. So pillow and requests, we're going to remove that. We're not going to do any requests like that. Python.env, this is useful if we have an environment variable file. We're not going to do one right now. Scikit-learn, we're going to leave that in there, but we're not going to do matplotlib either. So we're going to leave our data science and ML scikit-learn. We're going to use Plotly for visualizations, NumPy for anything we might want to do on the side, polars for the majority of our transformation code, pandas for any edge case stuff we want to do, and then obviously Streamlit. We should be fine right here to just use these packages, the latest versions of all of them. If I'm wrong, you're going to see me edit in the version numbers. There you go. So that's requirements text, and it sits in the folder. From here, you can see that they're suggesting now, Claude is saying, now do a pip install. And you do want to do this. It's saying pip install by reading the requirements text. And you do want to do this, but you want to leverage UV here. So in your command line, you're going to add UV, and then you're going to do your pip install. So let me run this. And yes, look at the speed right now of that. I mean, I can make a whole video on UV itself, but that is unbelievably fast. And so now you have all of your libraries that is required. Okay. From here, we can do a couple things. You can look at your VNV and you've got some stuff in your VNV, but we want to go ahead and make a folder structure, okay? We're not going to code anything still, so I'm going to start a new chat. But here I'm going to move to agent. We are in agent, good, for Claude Sonnet. So here I'm going to say, let's get some data involved actually, now that I think about it. Okay, so I have some data that I think I'm going to use, and you're going to give me one moment so I can put it in there. 1 second. Okay, so I have some synthesized data called streaming data to JSON. Okay. If we click on it, you'll see it's made up data for user information on a fictional streaming service, but it's got really straightforward things with it. So user ID, created date, all this. And this is really useful when it's a JSON object because it is text-based. You can pass one of these to the LLM and ask it to build things based off of that. So that's exactly what I'm going to do right here. Okay. Before I do that though, let's make a homepage. So let me get over here. I have a new chat, and I'm just going to ask Claude, I'm going to say, create a Streamlit homepage for my app. This app will be a one-page analytical dashboard, we'll say, to inspect streaming data for users from a from a a fictional, we'll say fiction, we'll just do this, a fictional streaming company. Okay, I'm going to come over and grab this guy here, and I'm going to say, here is a example of the data. Please create, let's see here, a series of filters and followed by two graphs. Actually, here's what I'm going to do. I'm going to just put that in there. It comes at the top here if you'll notice streaming data here, so it knows. Please create a series of filters at the top. We'll say relevant filters at the top, followed by two graphs in a tab set below the filters. I understand Streamlit's UIs, and so it has tab sets. So you have sort of a container, and then you have these tabs that you can select, and you can see different things within the tabs. And so you'll see that there. Yeah, I think we'll start with this. So let me read it again. Create a Streamlit home page for my app. This app will be a one-page analytical dashboard to inspect streaming data for users from a fictional streaming company. Here's an example of the data. It's attached. Please create a series of relevant filters at the top, followed by two graphs in a tab set below the filters. Please, I'm not going to say please, but I am saying please. It's hilarious. I'm not going to say please. I think I'm saying please because I'm recording myself and I want to be polite, but I don't normally do that. Okay, use polars over pandas unless you need pandas specifically for something, and you could, especially for date times, use Plotly for the graphs. Okay. This is, about what, a simple prompt's going to be. There's a lot more ways to set this up. I'm not getting into the cursor data files. I'm not getting into all these other little hacks you can do. I'm just coming right in and working with Claude and prompting my way to it. Let's run this and see what happens. Okay. It is going to help me. Thank you. Okay. Create an app.py. The requirements text is already finished. This is unnecessary, but it's fine. It's kind of trying to overdo it here. We won't add, we'll accept this. Yes. We'll reject this because we already kind of went through that. All right, so let's see what it did. I'm going to get the browser out. So it created a Streamlit dashboard with the following features. Page configuration, so a wide layout, which is good. That's kind of what we want. So up here, you got the set page config, the title, a page icon. Streamlit loves emojis and icons. Then below it, you've got a title about it being a streaming analytics dashboard. So it's clever enough to add that. It's using ST cache, which it's caching data that you load into it, which is cached as a pickle file, just FYI. But it's reading the JSON using polars, thank you, and it's caching as a pickle file locally, and that allows for much faster reads. Pickle is a very fast compressed file type, and it is faster to read than JSON because it's binary, not string like JSON is. Then you load the data into a data frame, and then from here, you've got 3 columns. And so the first column is a date range filter. That's a good choice to make. And let's see what they do here. So they take the minimum date and get the maximum date of the data. And then it creates a date range where ST date input. So that's a Streamlit component called date input. And it'll basically allow you to pick a date range, start and end, based on the date ranges that's actually in the data. So that's good too. The second column is a state filter, which I think is a good filter. And then the third is a show types. There's types of shows in the data. And I think those are all good relevant filters. There's 3 solid filters that are good. And filter the data frame based on the selection. So yeah, after you select all of them, you will filter the data frame itself based on the filters that you submit. It'll filter that data, then it will create graphs based on that data. So it went with viewing patterns and show performance. Okay, so it's making a column with polars called hour. So it's getting the hour from the created app, and then it is getting the watch minutes by taking the user watch duration seconds and divided by 60. And then it's grouping by the hour, and then it's aggregating it to the average watch minutes and then the number of viewers, and then it's sorting it by the hour. And this is this is good. This makes a lot of sense of what we want to do. So we're looking at the average watch minutes per hour with the number of viewers. This is before I even look at the application. I like that a lot. Then it makes a Plotly line chart and then shows it. That's in the first tab. The second tab is going to have show performance metrics. Okay, so something similar. It's going to look at total views. It's going to group by the show name. Then it's going to aggregate all the total views, and then it's going to divide the duration seconds by the show duration seconds, and then times about 100, which is going to give us like the percentage of what was actually watched totally of the shows. And then it's going to average that and say, here's the average completion rate. Here's the average amount of minutes per show that users are watching it. So I didn't even think that up. That's just done. Hello. And then create a bar chart for that. Okay, I think a bar chart probably works. So overall, I haven't touched any code yet, right? And this would be going a lot faster if I wasn't kind of explaining things to you, but yes, that's why using Streamlit specifically with your LLMs, Streamlit is set up very, very well for LLMs and for agentic building. It goes really fast. The way we launch a Streamlit app is pretty straightforward. We're in the folder. We have everything in the folder that we need already. We've got the application file in the root. We've got the requirements text already there, and then we got the data. So it's going to be reading the data while the app is running. To launch it, we will go Streamlit run app.py, and that's it. The server gets created and it shows up right in the web page. You'll see here it's running, it's building it. And we've got our first error. So strip from time, so string from time. And what do we have here? It has no attribute for that. Okay. So this is our first error. Let's go ahead. Well, actually, let's go back over to cursor. We're going to start a new chat. And we're going to actually just give it this here. It's got the trace back. I think this is all going to be pretty straightforward. Please, I like to put, you can fix this in, by the way, you can, right here, you can, if you hover over it, it tends to let you fix it from here. I like to copy it because I like to have it in the actual chat itself. Okay, so when you plug that in, you'll see it. I'm gonna get this over here. Yeah, it just shows the line. I think this will be a pretty easy one. So the time frame. So it used polars. I think this is one thing where it gets a little strange. That's where I think it tends to need pandas. It didn't bring pandas in here. It brought in date time. We'll see what else it wants to do. So it says the issue is looking at the JSON data. The created date field is already in a string format, but the code is trying to treat it as a date time object by calling, string from time on it. So we'll first convert the string to a date time object and then call string from time. So it initially thought it was already a date time object, but it's already a string. All right, so they modified the code. We're going to accept that. The cool thing about Streamlit is if you go back, you can do an always rerun, and every time you save there, it's like there's a hot reload, which is great. And then you can have the application update right there. So now the filters are running fine, but we've got our second error, which is the data frame has no attribute group by. So we'll go back over to cursor, and I will start that trace back here as well. I will start a new chat again. Not please. Again, I'm trying to be way, way too nice in front of y'all. So fix terminal error. Oops. I know you didn't see it. 1 second. Now where it's pasted. Okay, fix terminal error. Okay, it doesn't recognize the group by method. Yeah, I think it's because it's not correct. It needs to be underscored right. Yes, exactly. Group by without an underscore is either deprecated in Polars, or I think it was always an underscore in Polars. And so group by is probably like more Panda. So I got a little confused by that. FYI, Polars has a Kappa AI widget on their documentation page, which will give you all the latest context, which is nice. But this is one thing that happens with the LMs is some of the language and function names, they get a little outdated. So it made 2 changes, gonna update the group by. Okay, so it made some group by changes. We're gonna see if that was enough to fix it. And it was. We went back to our application and it is now here. And look at this. That's viewing patterns and show performance all right there. That was an application built in roughly 10 minutes based on data that I had with 1 prompt and 2 error messages. We're going to get into another video of adding some more elements to the Streamlit page here. I just wanted to get y'all's gears turning of how we can just create something in Streamlit with some data we have and our LMs like that really fast. I hope this really helped just to say, aha, I think I understand what Hoyt's going for here. And I have not touched any code yet. We will get into this some more. I hope you enjoyed seeing this. Like and subscribe to the channel. Got some more links in the description below. Y'all have a great day.